Welcome to this advanced Victron 3-phase and parallel training. We're going to run through the installation and configuration and some system design for the advanced systems involving 3-phase and parallel. These systems depend on you having sufficient understanding and experience with Victron equipment and tools. If you're in doubt, please see your Victron sales managers before undertaking a system like this with one of your clients. By the end of this video, you'll understand how to connect these systems together physically, how to program them, how to commission them, and then how to test to make sure they're working properly. 3-phase systems require 3 separate inverters. We'll begin by attaching them to the wall, using the supplied mounting plate, attach that to the wall, and then bring the units in individually. Make sure they're secure and level and evenly spaced to look good. It's important that the 3 multi-pluses that you use are all based on the same firmware ID number. You can access this number inside Victron Professional. It's possible to use Easy Solars, Easy Solar 2s, Easy Solar 2 GXs, Multiplus 2s, Multiplus 2 GXs together in the same installation, but it can be difficult to make sure you get 3 of the right ones, so it's far safer when ordering the units to order 3 of the same at the same time. We'll now connect the Multiplus 2s with the negative battery cables. If you're connecting a parallel system together, it's very important that these cables are equal length, so cut them all together to the farthest unit. If it's going to be a 3-phase system, this is less important. It's important that the negative cables are a continuous uninterrupted length between the 3 multi-pluses and the DC distribution. They can't be cut or switched in any way. You should also definitely connect these battery negative cables to the bus before we connect communications cables. Once you've got the lugged cables on the M8 nuts and bolts, attach the flat washer and then the spring washer and then finally the nut. Tighten it up with your wrench to the rated torque in the manual. Take your time making these important connections and definitely double check them all to make sure they're all secure. You also want to double check your polarity. Once you've got the negative battery cables in place, you can then connect the positive battery cables. In this case, we can isolate these through a switch. We'll be using a double pole DC isolator, but only using the positive pole of it. If you can find a single pole DC rated isolator, then you can use that too in this case. This one's current rated to protect the cables. It's important when you're inserting cables to make sure there's no stray copper wires that might cause a short circuit. Insert the cables through the glands in the bottom of the Multiplus 2s, making for a neat installation. It's also important to make these connections before you connect any battery or power. Connect the cables in the same way you connect the negatives, with the flat washer, then the spring washer, then the nut. And double check the cables for firmness and good connection. As we cut the cable, we'll now be making the connection from the bottom of the isolator to the battery cable, which will run down to the DC bus. Again, make sure these cables have no stray wires. And check them for firmness. Once all the positive cables are neatly connected and run through the trunk or through a back wiring system. We can double check all the connections, make sure everything's secure and looks good. These cables can run a high current, so it's really important these connections are right. If you've got a ground connection, this is where it's connected to the chassis of the unit. Ground connections vary according to your region, so please follow your local wiring rules. We can now connect our battery negative cables to our DC distribution. In this case, we're using a Victron distributor. If you remove the front cover and then the plastic plates over the negative DC bus bar, you can attach the lugs from the battery cables onto the bolts and then tighten them up with the nuts. As with the others, it's a flat washer, then a spring washer, and then the nut. Again, these should be the first connections you make. Once all the nuts are in place, you can tighten them up with the ratchet and check to make sure they're nice and secure. In this case, we've color-coded the battery negative cables and battery positive cables in case we need to identify which unit is which down the track. Once the cables are firmly secure, you can reattach the plastic protection. Now in this case, we've already put our mega fuses over the top. Once the mega fuses are installed, which are appropriately rated for the 48 volt system, you can get them in 24, 36 and 48 volts, you can then put the battery positive cables on. Remember, these cables are also protected and isolated up with the DC isolators up at the top of the cables before they enter the inverter. So in this case, they're double fused. This is for convenience as much as safety, but make sure that the cables are appropriately rated for the fuses that types that you've got. Once these cables are securely in place, you can then attach the battery cables to the DC distribution bus bars. There are larger connection points on each end. Be very conscious at this point to observe polarity. In this case, this is using a lithium battery, and the lithium battery is not yet switched on, so there's no voltage at these terminals. Double check to make sure your polarity is correct. Before closing the main fuse to the batteries and switching the battery on, definitely check the polarity. Once you're certain of the polarity, close the main battery fuse. You can now check polarity at the bus bar. Remember, the multis are still isolated at the isolator that's closest to them, so in the event of a reverse polarity situation, they're not going to be damaged. We're going to double check them again. Now we've tested and observed correct polarity and voltage at the DC distribution, we need to test polarity and voltage at the multi-plus 2s. This is done before switching on the isolator at the multi-plus 2s. We want to check polarity and voltage as expected above the fuse. Once we've checked it, observed that it's correct, we can close the fuse, close the isolator, and then check the voltage and polarity at the battery terminals on the multi-plus 2 itself. We want to do this for each and every multi-plus 2 that's connected. This is critically important. Incorrect polarity at the multi-plus 2 can destroy the unit and is not covered by warranty. So take the time to check and observe correct polarity and voltage at each multi-plus 2 before closing the isolator and switching it on. Depending on the fuse you're using, there can be high inrush current on the multi-plus 2. So you may see a spark. In this case, the isolator is sealed up, so we won't see any connection point. But be mindful, doing this repeatedly can burn out the contacts on your isolator, so make sure it's appropriately rated for DC current. Now we've tested the voltage and polarity and we've got our power cable connections in place, we can move to the communications cables. We're going to connect each of the Multi+2s together through the VE bus ports. This is done with the standard RJ45 Cat5 cable. Victron can supply this in various lengths when you're buying your equipment. We highly recommend using manufactured cables. Don't try and make your own cables for this. This communications cable is critically important for the functioning of the system and can cause errors if it's not done properly. Each unit is daisy chained into the other. Please consult the wiring diagram for exactly how this is done. The exact location of the VE bus port will vary depending on the unit you've got. Here you can see it's located on the bottom. Once the units are all connected together like this, they won't function properly until they're properly programmed. You'll also need to connect another cable into your Mark III to USB adapter for programming. It's also possible there'll be another cable to connect to your GX device. For the programming stage, please leave the GX device disconnected. We'll connect it again later. In this example, we also have a CAN bus connected battery. It's important to connect the CAN bus battery at this point so that it stays powered on while we commission the system. For further information on how to connect and configure your CAN bus battery, please see one of the other videos. Once we've got a secure power supply and the comms cables are in place, we can neaten up the installation by covering back up the trunking. Don't completely cover up the Multi+2s, we still need to make connections and check. You can see here, even though the multi is connected and powered on, it's producing 0 volts because it's connected to the other units. It's important to do a firmware update on the system before programming, as the firmware update will wipe all the settings. There's a separate video for firmware updates on the Multi+ in Victron Professional, or you can Google Multi+ firmware update. For multi-phase systems, before switching these units on for programming, you need to link together the AC output neutrals of the multis. This guarantees the voltages between the multis have a common reference point. The 3-phase loads run without neutrals also require this precise reference voltage. Once the AC output neutrals are linked, we can then go to the other AC wiring, although this is not essential to do before programming the units. Remember to take care of the AC input phase rotations and have them match to each of the units. So phase 1 matches the phase 1 programmed unit, and so on. If possible, configure the systems so the AC input phases matches the order on the wall. However, if the units are wired up with an incorrect phase rotation, this is possible to correct in software. We've now made all the physical connections we need to do with the Multi+2s. We're going to go through some of the commissioning processing steps. Once the units have been connected together with the VE bus cable, they won't be producing 240 AC anymore. You'll see they'll be flashing lights on the front. The exact error light code may vary, but it'll look something like an alternating light, and the units won't be producing any power. To help demonstrate this, we've actually removed the Multi+2 GX and replaced it with just a regular Multi+2. So we can now see the 3 units side by side as they are represented in the software. To begin, we're going to need to open up one of 2 tools. Now there's 2 options here. They're available from the download site on the Victron website. The one we're going to go through is the VE Bus System Configurator tool. This is part of the VE Bus tools set, and it gives us the most options. There is another option, another tool to use, which is called VE Bus Quick Configure. VE Bus Quick Configure is a wizard, so you can just follow the directions that it gives you for the programming part of this. But for now, we'll use VE Bus System Configurator. I've connected the Multi+2s with the MK3 to USB adapter and disconnected the color control and any other accessories. I'll make sure that the MK3 is connected. It is. I'll open up the VE Bus System Configurator tool. I'll then go up to the Configure menu, select the COM port and Auto Detect. It'll scan the ports and look for the devices. It'll remind us again to disconnect any accessories we might have connected, color controls, digital multi-controls, etc. We have those disconnected, and we can now see the 3 units as unconfigured devices in the software. Now the 3 units are going to be presented in a relatively random order. To find the right one, we can right click and select flash LEDs, and I'll show you more about that in a second. The first thing we're going to do though is head down here where it says single phase as a default, click that button, and then we can select 3 phase as an option. There's other options here as well for different configurations. We won't go into those right now. I also want to keep 1 AC input selected. We now have 3 buckets we can put these multi-plus 2s into. So, to find out which unit's which, I'm going to right click on it. I want to select the first phase first. I'm going to click flash LEDs. Now, in this example, the first unit is the first unit, and you can see the LEDs adjust. I'll stop selecting that, and then click the multi and drag it over to L1. I'll then right click on the second unit, flash its LEDs. In this case, it's the 3rd unit on the wall. So I'm going to stop flashing LEDs and drag it over to L3. Lastly, the only unit left, the unit in the middle. I'm now going to drop it in the middle. It's important to get your phases correct to make sure that the incoming phase 1 is matched with the multi that's programmed to phase 1. Otherwise, you can have issues later on with the installation. With all of the units now selected in 3 phase, assigned to the right phase, I can now click Configure and Send Configuration. The Bus System Configurator tool will now send that to the multis. The units will restart, and they'll all show green lights, and they're now synchronized as waveforms. These units are connected in 3 phase, but we can also use this same configuration tool to configure them into parallel. I'll show you how I do that now, and then I'll convert them back to 3 phase again. I select back on 3 phase. I select single phase with 1 AC input. And now I drag all the units onto that single, and then send the configuration again. We now have all 3 units connected in parallel. There's other things to consider in parallel system design, and you should cover these off in the manual. The most specific is on the AC output. There needs to be equal resistance on the AC output as well. This is the AC wiring diagram for a parallel configuration. Remember, you can add 3 phase and parallel systems together to build very large systems. I'm now going to convert these systems back to 3 phase. Make sure I've got the right unit. That one's phase 1. That one's phase 2. And that one's phase 3. Now that I've got the units configured into 3-phase configuration, I need to adjust their settings in vConfigure. Now I can't just open up vConfigure as I normally do. I need to be able to open up vConfigure and assign it to a particular unit. To do this, I select the phase that I want to use, right click on the multi, and then select vConfigure multi. This will close the Bus System Configurator tool and open up vConfigure. It's important to make sure that the assistants especially are loaded on each unit individually. All 3 units need to have the assistants loaded, especially the ESS assistant for this example, but other settings as well may need to be set to all 3 multis individually. Now the unit's loaded up in vConfigure, I'm going to head over to the Assistants tab. It tells me I need to turn off the virtual switch first. I'll do so. I'll then add the assistant, ESS. I'll run the assistant and just select all the default values in this case. Now the ESS assistant's there, I want to save this configuration. And then I want to send these settings to the Multi Plus. Now it'll ask me where I want to send the settings. I can't send assistants to all multis at once. So I have to select this device, and this device is the one that I've selected in VE Bus System Configurator. I'm going to send the assistant. Now, when I'm sending the assistant, one of the units which is receiving the assistant will switch off, and the other two units will drop out at the same time. In a three-phase and parallel system, all units must be on and working, or else none of the units will work. They rely on each other for synchronization. Once the configuration's been sent, all units will restart, and they should all connect and resynchronize with each other. The assistant's been successfully sent to the first target, and all the units are back on now. You need to remember that we're only changing this setting for this individual multi. So some of the values can be different between units, and they'll combine from the perspective of the whole system. For example, setting a 32 amp AC input current limit will actually combine to a total of 96 amps across the three phases. Another example is the DC charge current limit in the charger tab. If you've got a known target DC charge current, for example 120 amps on a 1000 ampere hour battery, then each unit should be set to 40 amps to make the total of 120 amps of charge on a three-phase system. Of course, normally you'd adjust other settings as well in VE Configure, but for now that's enough. I can now close it. It'll reopen the VE Bus System Configurator tool. I'll head to my second phase and repeat the process, selecting VE Configure Multi, loading that configuration file that I've just had in, sending it to the unit, and then that'll be that. And then I'll repeat it again with the third unit. Now I've opened up, I can load the settings. There's my assistant. I can then send the settings to the second multi. Once again, it'll switch off once sending the assistant, leaving the other two units off as well. And we're done. Now you can repeat that procedure for the third and final unit. Once we've got the system configurations loaded into each of the multis through VE Configure via the VE Bus System Configurator tool, we can disconnect the MK3. Once the MK3 is disconnected, we can then reconnect the color control or other accessories like the digital multi-control. This is an important step if you have a GX device to confirm the system's working as expected. I've now disconnected the MK3 to USB adapter. I've connected in my GX device, in this case color control GX, and loaded up the remote console, and we can see here now the three phases appearing under the AC loads. Now this is a basic system at the moment, there's no AC input and there's no solar charge, but for testing to make sure that this system is correctly configured, this will show us what we need to know. I'll then head into the menu. You can see there the CAN bus BMS menu. We'll go into the Multiplus 2. It's inverting, and already we can see a lot of the settings are the same. The first one actually is important. The switch is marked to on. Once these units are each connected to each other like this, switching their physical hardware switches on and off will cause an error to form on the system. Each of the units is synchronized, and if one of them is lost, presumably the system thinks there's a problem or a fault, it'll report that error through the GX device or to the VRM portal and say, hey, I'm missing one of the other devices in my system. If you wish to switch the unit off, they have to be switched off in a synchronized way. This can be done through a GX device, or you can also run an assistant to switch off with an external control. In this case, I'm going to leave them on, but that's the way I'd turn the system off if I wanted to, through this software switch. Also important here to note is the input current limit. This is now combined, so this input current limit is for each unit, but each unit can produce that much power, so you have to sort of divide the total number here by 3, or multiply it by 3, depending on how you want to think about it. So if you only want to allow, let's say, 30 amps in, you'd set this to 10 amps, because each unit will allow 10 amps in, and that'll allow a 30 amp connection in, if all units are connected to the AC input. Now there's no AC connected in to these systems at the moment, no AC in or AC out, but we can see there's 3 phases shown in the menu here, AC out L1, AC out L2 and AC out L3, and all is looking pretty good. You can further confirm this by using a multimeter to take a voltage reading between the 2 actives on the units. Now be careful doing this is going to give you 400 volts, so make sure your multimeter is appropriately rated and you're suitably qualified to be taking readings at those high voltages, because it can be quite dangerous. If you have any issues connecting the GX device to this 3-phase system, especially to begin with, it can help to have all the 3 units turned on first before they're connected to the GX device. You can then connect the GX device and it should find the 3 multis. If it doesn't, you can reboot the GX device through its menus. This is found in the Settings, General and Reboot. Now we've tested the system and make sure it all works correctly, we can replace the covers on the front of the multis to make sure everything looks neat and is safe. For further advanced options for 3-phase and parallel systems, please contact your sales managers. We've now installed, programmed, commissioned and tested a Victron 3-phase system.